Okay, so we've got a picture here involving a circle and some triangles, and it looks like we're having to prove that shapes are similar. So we recognise the word similar means one shape is an enlargement of the other, but all, and this is the important bit, all corresponding angles are identical. So basically, if we can prove that both the triangles have identical angles in corresponding positions, then they must be an enlargement of each other, or similar certainly. So let's go through. What have we got? We've got a shape that is a cyclic quadrilateral. So if we were to call angle EAB x, for argument's sake, it doesn't really matter which we go for, then we know that this angle over here would be the opposite, and those two have got to add up to 180, so that'll be 180 minus x. And if that's 180 minus x, then this must be x. Okay, so that gives us a starting point. And because we've got this idea that we're working with triangle ECA, and we've got the triangle BCD, so we've got two triangles with x in it. Okay, so if I decide to call this y, then this must be 180 degrees minus y, so therefore this must also be y. And this must be 180 degrees minus y minus x. And so what we can see then is we've got the big triangle AEC, and that was x, that was y, and this is 180 minus y minus x. And then we've got the corresponding triangle, so where that's going to be C, that's going to be D, and that's going to be B. And the angle there is y, the angle there is x, and this one's 180 minus y minus x. Okay, so what we've done then is by showing that the labelling of this triangle, the labelling of this cyclic quadrilateral allows us to use the idea of opposite angles set up to 180, then we can show that this is x and this is x, this is y, and this is a common angle, which is the same in both triangles. So therefore we've proved that the two triangles are similar, because all corresponding angles in both triangles are identical, so one must be an enlargement of the other. It's saying you must give reasons though, so obviously we've got to go through now and decide how we're going to write that. So we're going to say let angle EAB equal x degrees, then opposite angles in a cyclic quadrilateral add up to 180 degrees, therefore EDB equals 180 degrees minus x. Angles on a straight line add up to 180 degrees, therefore CDB equals x degrees. Same idea for angle AED equals y degrees, therefore CBD equals y degrees, and angle ACE is common to both triangles ECA and BCD. Therefore, both triangles must be similar, as all corresponding angles are identical. So anything on those lines, basically by adding on the information to the picture, showing clearly what you're doing, giving some reasons for why the angles are the same. We should really give a reason here. Angles in a triangle add up to 180 degrees. So again, we're giving reasons throughout for why we're choosing each of the bits. We've drawn out the two separate triangles, filled in the letters we chose, and shown that the corresponding angles are all identical, x and x, y and y, and so forth. And then we've written a sentence or two to try and explain why it all worked. That should be enough to give you all the marks. Again, it's being clear, opposite angles in a cyclic quadrilateral up to 180, angles on a straight line, and so forth, and so forth, and so forth.